how do we structure our networks today? Well, we don't do it in a flat way. Flat networks are those that basically have one tier. Now, we see this sort of architecture in our home network. It's okay to have a flat network in the home where you plug everything into a switch. And by the way, this looks like a bus topology, really. That's not how it would work. All of these would feed directly into the layer 2 switch and then up to a router. So this is definitely the sort of thing that we see in our home, where our router is doing NAT, it's doing DHCP, it's got a default route going to the internet, but that isn't going to work for an enterprise network. We need a structure to make this work because we have to account for the server farm, we have to account for a large number of devices, we need redundancy, and there's got to be a cookie cutter approach that I can repeat and I can know that it's with sound design and architecture in mind. And we see that with a hierarchical network design, and this is a hierarchical network design. Do you see the hierarchy? Well, think about a hierarchy in the context of social systems. In social systems, we have kings, we have nobility, and then we have serfs. And so down below, we have our serfs. This is something we're going to call the access layer. More on that later. And then the nobility, the middle layer, and then the most regal of the devices that live in the core. And what this allows us to do is kind of have a tiered structure. This is tiered. Bottom tier, middle tier, top tier. And if we need to add more devices, this affords us scalability. And notice all the extra connections between these devices? Well, that is there for redundancy as well. That's important. We need our redundancy, and I would want to see redundant connections between all of the different devices. And we get that with a hierarchical network design if we're following this model. Let's look more at our network model basic building blocks. Now, what's interesting is these three different layers are repurposed in other contexts beyond just campus networking. They are the access layer, the distribution, and the core. Now, if you're going to speak Cisco lingo, you need to be able to speak about this with some intelligence. You are expected to know the significance of the access, distribution, and the core layers. The access layer is about getting connectivity. And what we're typically going to see are a bunch of these layer 2 switches providing the port density that is going to get us onto the network. Now, those access layer devices are going to connect up to distribution layer devices. These distribution layer devices are going to give us connectivity to the outside world beyond the VLANs that exist at the access layer. So you're starting to get a little bit of a picture, hopefully. Now, what's important is we have a different kind of device at the distribution layer. It's a layer 3 switch. It's a multi-layer switch. Those are interchangeable terms. I don't want you thinking layer 3 and multi-layer switches are different. They are interchangeable fully. A lot of people like to say multi-layer switches now. So I guess there's a little bit more people using that term, but it's not of significance. Now it says here policy-based connectivity. Policy-based connectivity really means manipulation, security. So what sorts of things can we do on a router? We can do route summarization. We can do policy-based routing. We can do security through access control lists. That's what we're talking about there. And then we have the core. Now, this is where we have a possibility where we don't have a core. A core is not always assumed. And it depends on the size of our network. If we're let's say a small, medium business, we may not need a core. But as we grow, we begin to need this area. And it used to be that we'd have layer 2 switches in the core sometimes. But now, if we have a core, it's a layer 3 core. And a layer 3 core is facilitated by a multi-layer switch or a layer 3 switch. See how it's easier? If I say it's a layer 3 core, it makes sense to just say, hey, it's a layer 3 switch. So it's one of the reasons why I like to use the term layer 3 switch. It just makes more sense. So the core is about nothing more than throughput and redundancy as well. Because if we have a single point of failure, that's going to be a problem. If we have an outage, that's going to be a problem. If I were to scratch off one of those multi-layer switches, say, nope, it went away, lost power, that would be a problem, wouldn't it? That would be a problem. So we want our cake and we want to be able to eat it too. And so we have typically 2 multi-layer switches in the core of our topology. And we also expect high-speed connections here, 10 gigabits per second, 40 and above, and channelized high-speed connections so that we can aggregate bandwidth when we forecast bottlenecks.